So if you take a look at this problem is complicated because you got two fractions separated by a plus or minus, right? Two fractions. Just as you know, say for example, 3/4 minus 2/3. You have to make sure you have common denominator, right? So you have the common denominator will be you multiply 3 on both on top and bottom, you multiply 4 on top and bottom before you can actually combine them, right? We learned this in grade school, right? This is 12 on the bottom, this would be 9 minus 8, right? Then you can combine them. You cannot, right? You can never do this, right? You can never say, oh, this is 3 minus 2 over, whatever. Like you can't do that justifiably. So you have to find a common denominator. That's number one. So in your head, common denominator. Well, the denominator for this one is x squared minus 25. This one is x plus 5. You should, given enough practice, you should recognize that, wait a minute, x squared minus 25 is essentially x plus 5 times x minus 5, isn't it? Right? So f of x must equal to, in this case, on the bottom, immediately you can say, oh, this is x plus 5, x minus 5. And then on the top, it doesn't change. Now, you don't need to go any more steps forward other than just writing the rest of the stuff out, right? Because this way, you can keep track of what you have. Then you look at this and say, okay, then what does this one gonna lead me to think? This one led me to think that, okay, I had made this into two factors, but then I want to find common denominator. I notice that the second fraction is merely a missing part of this one, right? So common denominator just simply means I need to multiply this one by x minus 5, I will have common denominator. But if I do that, I must do the same on the top, right? I must do the same on the top. So f of x turns out that on the bottom will be x plus 5 times x minus 5. And then I'm going to go ahead and combine the top. 3x minus 5 minus 2 times x minus 5. Right? So this is just my step by step. I let the equation informing what I need to do next. I don't necessarily know that I'm going to end up here. It's the steps that led me to there. Okay? So f of x then is equal to, on the bottom, I still keep it as x plus 5, x minus 5. On the top, I'll go ahead and multiply this out. 3x minus 5, and then this is negative 2 times x, right? So it's minus 2x. Negative 2 times negative 5, so it's positive 10. Yeah? So far, so good? So then f of x becomes like 3x minus 2x is just x. Negative 5 plus 10 is just positive 5. And then on the bottom, I get x plus 5 times x minus 5. Now on the top, I can think of it as that. So what does this lead me to? I can rotate this down a little bit more. What does it lead me to? Yeah? Yeah, because I can what? I can cancel. Woohoo! Cancel. Be like that. Makes it simplify, right? So then f of x becomes 1 over x minus 5. Wait a minute. I know this. This is easy, right? This is essentially, right? Essentially, we have learned this before. Essentially, if we have x, f of x is equal to 1 over x, that just looks like this, right? Right, with the asymptote over here, asymptote is over here. But with this minus 5, what does it do? What does it do to the graph? Move the graph to the right. Yeah. So my graph is going to have positive 5 here, positive 5 here. And then I have a vertical asymptote here. I have a horizontal asymptote here. And then my graph is going to look like this. Now, before I hand this off and as my final answer, I had something to consider. Who can tell me what I should have considered even before I got gone to this place? Yeah, Ali? That's right, x plus 5. Over here, I notice I had two factors in the denominator. This tells me, right? This tells me that x cannot equal to negative 5 and x cannot equal to positive 5. When we end up here, we say x cannot equal to 5. We know that this one gives us the vertical asymptote, because if I put 5 in here, I get 1 over 0, right? When x is equal to 5, we get 1 over 0, which is undefined, which is vertical asymptote. Okay, but what about when x is equal to negative 5? Well, if you put x equal to negative 5 into this equation, you end up with 1 over negative 10. But is this equation that I'm supposed to work with? No, it's the original equation. And this equation did not change until you get here, right? From this steps all the way to this steps, f of x remained the same until I start crossing things out. When I got rid of x plus 5 term, I fundamentally changed the original equation. This is missing some information. So this final answer is missing that. So that's why we had to go back to depend on this one. So if I go back to this one, I put negative 5 in here, I will end up with a 0 over 0, isn't it? I will end up with 0 over 0, which is what we call the indeterminate, which gives me open circle. So at x equal to negative 5, right here, I will put a open circle on the graph. Right here. And here you go. That is the solution for this problem. Question, yeah? Questions? Any questions? Is it clear? Let me recap. Several places where you can get tripped up. When you start out with this, you notice that it's fraction. Whenever we think of fraction, it's possible, especially in this chapter, fractional graphs are called a rational function. And rational function, the biggest, most common rational function we learn is this kind. Okay? It's this kind. So it's likely that I'm going to give you a problem where it's complicated, but you're going to simplify, and then at the end, boom, looks something like this. So the question is, how do you simplify? Well, immediately you should recognize some of the tools you learned before, right? In this case, x squared minus 25. So you can factor it out. Then the second thing is you say, okay, I have two fractions, I must use a common denominator. So when you do common denominator, you do this properly according to logic and the tools that you've done in the past, you should end up with this version. When you end up with here, then you can cross things out. But when you cross terms out, you have to be careful that you don't cross away or get rid of important information. So in this case, you quickly identify that x cannot be -5, x cannot be 5, and then you go through this analysis and say, okay, what does it do to the original graph? This one makes it 0/0, this one makes it 1/0. So this is undefined, which is asymptote. This one is indeterminate, which is open circle. You take the final graph it out, identify the asymptote, identify the open circle, then you're done. Right? Very systematic, very straightforward. All right? Other questions? All right, take out your notes. We're going to go to the last section of this chapter. Go ahead, if you have an idea, jot it down. If you have an idea, jot it down. It's equal, right? Okay, so if you look at this equation, this is a simple one. We start out with this discussion with a simple one. Simple but a little tricky. Simple but a little bit tricky. Okay? You have x squared over x plus 5 equal to 25 over x plus 5. They both are in fraction form. The bottom is x plus 5 and x plus 5 on both sides of the equation. So technically, could you say that this just really leads to x squared is equal to 25? You could do that, right? Okay. Now, in order to solve for x, you square root on both sides, yeah? And when you square root on both sides, you end up with x is equal to 5. Is that the only answer? Yeah, isn't it? Plus and minus 5? Because negative 5 squared is equal to 25 too, right? No? Yeah? But let's check. Check our answers. Right, so you have x equal to 5 and x equal to -5. You're checking your answer. I put 5. Do I put 5 in here or do I put 5 in here? To the top one, right? Not this one. Top one, right? So if I put this one in there, I got 25 over 10, and then 25 over 10. Right? The question is whether so you checked out. You checked out. So this is our answer. Now, x is equal to -5. Do I put it back in here or do I put it back in there? Which one? If I put -5 back into here, the answer will checked out. But that's not our original equation. This is our original equation. So if you put this -5 here, I get 25, right, over 0. Now the question is that equal to 25 over 0? I mean, yes and true, but then what would this be? This is undefined. So we will get rid of this. This is what we call the extraneous solution. All right, this one, solve this. Phi x over x minus 2 is equal to 7. It's 10 over x minus 2. What does it look like? Okay, let's take a look at here and see if you get it right. Okay, we're gonna go over this. There are a couple ways to solving this. So I'm gonna show 2 different ways. And I saw. All right, focus here. Okay, so there are 2 different ways of solving this. I'm gonna just do 2 different methods. So option one. Option one, I saw many of you have done this. You kept this as phi x and and then x minus 2, and then you try to do this as, figure out the common denominator. So remember I say this can be written as 7 over 1, right? And then 10 over x minus 2. So then you want to find the common denominator, so you just multiply x minus 2 on here. So you can do that. And then, so you end up with 5x, x minus 2, and then you got 7x minus 14 plus 10, x minus 2. Yeah, so some of you did that. And then keep simplifying this, 5x, x minus 2, and then 7x minus 4, x minus 2. Now, if this is it, and both sets of equations are both over x minus 2, then I can say that this 7x, oh no, not 7x, 5x can set it equal to 7x minus 4. Right? I do that. If I do that, I put this over here, right? Move the 5x to this one side, so it's 2x. And then over here is 4, so x is equal to 2. X is equal to 2. Okay? X is equal to 2. Now, I'm not done with this method, okay? I'm not done with this method. I'm going to come back to it. I'm going to go to option 2. So option 2, so I'm not done with this. I'm coming to option 2. Option 2, I have 5x over x minus 2, and I have two different terms, and this term is 10 over x minus 2. I can take this whole thing, I can move it to that side. Right? I can move this to that side. So I end up with 5x over x minus 2 minus 10 over x minus 2 is equal to 7 over 1. 7 over 1, right? And then I get 5x minus 10 over x minus 2 is 7 over 1. We learned from prior math courses, we know that we can, if you have equation with this looking like this, you can cross multiply. Have you heard the term cross multiply? Okay, so cross multiply is you just take the bottom part and you multiply it up. Take the bottom part, you multiply it up. Right? So 1 times this is just 5x minus 10, and this over here is just 7x minus 2. So you end up with 5x minus 10 is equal to 7x minus 14. So you got 2x is equal to 4, x is equal to 2. You end up with the same answer, right? Multiple pathway to the same place. Now, yeah. Say again?
So, for example, you take, so 5x, so you want to get rid of the common denominator, you multiply that as you multiply with x plus 2. Could you do that?
Yeah, so option number 3. Option number 3. You have 5x. I won't solve the whole thing for you here, but we can give it a shot. Option number 3 is this: is that you have 3 things here, and then think of this as over 1. You can multiply this by x minus 2, this by x minus 2, this by x minus 2. Then you end up, this plus out, you end up with 5x here, and over here is 7x minus 14. And then plus, this plus out, you end up with 10. Right? You see it? And then this is still going to give you 2x is equal to 4, and therefore x is equal to 2. So far, so good? So you have 3 ways of solving this equation. However, you have to go back and check. You can go back and check. But here's the thing. If you look at this, you should immediately say, well, wait a minute, I have x minus 2 in the denominator. That means x cannot equal to 2. X can't be 2. Because if x is equal to 2, it will make that undefined. But our answer happens that our x is equal to 2. But then it says x cannot equal to 2. That means this is an extraneous solution. Now, if this is the only answer, and the only answer is the extraneous solution, that means this equation has no solution. That's your answer. Plus 6 over x minus 3 equal to 2x, x minus 3. Now, hey, you know how to do this, because we just did one similar to this. Let's go down the speed. Let's go down the speed. All right, ready? Ready? Let's do this. Option 1. All right, ready? Come on. Option 1. All right, which option do you want me to do? Which method do you want me to do? Common denominator first? Okay, common denominator. All right, so this one is x over 1. This is 6 over x minus 3. This is 2x, x minus 3. So common denominator is x minus 3, so I need to multiply x minus 3 and x minus 3 like this. Right? So if I do that, I end up with x squared minus 3x over, well, the whole thing on the bottom is x minus 3. And then this is plus 6. And then it's equal to 2x over x minus 3. Right, so this will be, so then we can say, hey, the top, since the bottom is the same, the top can be the same. So we say x squared minus 3x plus 6 is equal to 2x. Can I do that? So then I'll move the 2x on this side. I end up with x squared minus 5x plus 6 is equal to 0. Now, why do you think I moved the 2x over here to make the equation look like this? Why? Yeah. I can factor, that's right. I can factor and set equal to 0, then it will be very easy to find the x, right? So if I factor, this will be x minus 2 and x minus 3, isn't it? Right? So what that means is x is equal to 2 and x is equal to 3. But not so fast, because when we look at the top, x cannot be 3, because it will make it undefined. So this is a extraneous solution. And then we pass it out, and then box this one. You got it? Very nice. All right. Option. I was just writing out different options because we all think differently. Another way I saw over there in the back is we can move this to this side, right? So we can take this and x, then we can we can keep the 2x here minus 3, but then we move this to here, so it becomes minus 6 over x minus 3, right? And then so this one becomes x is equal to 2x minus 6 over x minus 3. Now, by doing so, I can make that into x over 1, and then I can just do the cross multiply. So I do a cross multiply, I have x times x minus 3 is equal to 2x minus 6. That just becomes x squared minus 3x. This is 2x right here, and minus 6 over there. And then move everything onto one side. I end up with x squared minus 5x plus 6 equals 0. I end up with the same factor. X is equal to 2, x is equal to 3. X cannot be 3, extraneous, and this is the only answer. Boom. There you go. Now, I want to simply just use an example in your textbook. This is an example 5 on in the textbook. Example 5, page 228. Now, you don't have to flip to it. I'm going to tell you what the problem is asking, and then we will gradually change that. Here says, paddling with the current in the river, Jake traveled 16 miles. Okay, so I'm going to write this down in terms of sentence. Paddling with the current, the current of the river, right? The river current, right? Jake traveled 6 miles. That's the first sentence. Second sentence, it says, even though he paddled upstream. Now, so as the sentence says, the second sentence says, Jake, even though he paddled upstream, then you can go back into the first sentence and say, okay, paddling with the current, that means this is downstream, right? Even though the sentence didn't say that, you should be able to make that conclusion. That would be very important when you set up an equation. So with upstream, right? Upstream is much harder to paddle, right? Because going up, water is pushing you back down. He paddled for an hour longer. An hour longer. But then he also only traveled. Oh, I'm sorry. This he traveled 16 miles. The first one is 16 miles. He only traveled down upstream. Only traveled 6 miles. Okay. And then the next one is in still water. Jake paddles at the rate of 5 miles per hour. 5 miles per hour. So here it says, the question, here's the question. What is the speed of the river?
No.
Okay, we have 8 minutes to solve it. First thing we need to think about is the definition for the rate of change, the rate of the speed. And in physics, you might study this, or if you just simply look at this, speed, right? He paddles a speed of 5 miles per hour. So speed, which is the rate, is 5 miles, which is a distance over time. So speed is defined by distance over time, right? So you can just look at this, then you will know the definition of the speed, right? Rate, distance, divide, time. Very simple. Now, with this, you can also manipulate in this different ways, right? Just because speed, you can say speed over 1, right? So you can move this around if you like, right? So this could be speed times time is equal to the distance, or this can swap, right? This can swap. Time is distance over speed. So just with the one equation, I can come up with all 3. Right? They all make sense. So over here, paddling downstream, Jake traveled 60 miles. It takes quite a bit of time, right? It takes how much time? We don't know. But we can say downstream, downstream, time it takes is equal to distance divided by speed. Distance is 16 miles. Speed is the speed that Jake is paddling normally. And because downstream, you're helped by the river. Speed of the river. Now, what do we know about this of Jake's speed? What's Jake's speed of paddling? Yeah. 5, right? 5, right? In still water, 5. So I can replace this by 5. Okay. What about upstream? Upstream, this is where it's a little tricky, right? Upstream is right here. Now we use the first one to come up with the first equation. The second one here says an hour longer. So it's the downstream time plus 1, right? Right? Jake goes downstream, travels 60 miles with the same amount of time. Not only with the same amount of time, he has to add 1 more hour going up. And he only travels 6 miles. So that means this is equal to 6 miles speed of Jake minus speed of the river, right? Because the river is pushing you back. So it's subtract. But we also know that speed of Jake is 5, isn't it? So look at this. We have 2 equations. Equation number 1 and equation number 2. Now, cool part about the equation number 2 is I can rewrite this equation, and I can rewrite this as t is equal to 6 over 5 minus SR by speed of the river minus 1. Now, so if I have an equation that is set up as t, and this one, I bring this plus 1 to this side, make it into minus. Right? I move this 1 plus 1 over here becomes minus.
Oh, okay.
So now take a look at this. Take a look at this. I'm going to erase this part. We're going to put my final equations here. Take a look at this. I have equation number 2b. Equation number 2b. Can I look at 1 and 2 and say, well, this is a complicated expression, but it's equal to t. This is a complicated equation equal to t. Then perhaps I can set them equal to each other. T equal to t, right? So I can say 16. Let me just write it down. 16 over 5 plus SR is equal to 6 over 5 minus SR minus 1. And then your job is to solve for SR. This equation looks very similar to what we've done before. Yeah, that makes sense? Okay, so this is getting to here is a one major hurdle just to get there. So you take this equation, this description, set it up, and then come up with the equation. By solving that equation, you come up with the answer. But getting here, you get 80% of what you need. So if there's a 10-point problem, get there, you get 8 points. Now solving it is a different story. So let's solve it real quick, okay? We're gonna solve this real quick. You ready? You ready? Common denominator, right? Common denominator. common denominator, I can set this 5 plus SR. I can multiply this by 5 minus SR. And set it equal to 6 over 5 minus SR. But this one I will multiply by 5 plus SR. 5 plus SR. Minus 5 plus SR times 5 minus SR. 5 plus SR. 5 minus SR. So I can basically ignore the bottom. I can just work through the top. Right. So the top, right, you got 16 times 5 minus SR is equal to 6 times 5 plus SR minus 5 plus SR, 5 minus SR. But other time, but when you solve this, you will find, you will solve for SR as our final answer. Okay, that's just a matter of algebra. Okay, have a great day.